So by means of introduction, this is looking at algorithm design. We have actually already seen most of this before, and you guys in particular have done a lot of work on algorithm design, and therefore the rest of the work we'll be concentrating on is just updating your knowledge there. There are 7 or 8 standard algorithms that are defined in the software design development syllabus and support documents that you need to know, you need to recognize, identify, and be able to manipulate. They are standard algorithms throughout the course, and they are the ones that will appear in your HSC exam. So for example, finding a maximum value in an array is one of the standard algorithms. If you look in the development, we have declarations of the array size and content, declaring the maximum value to be 0 because all the values start above 0. For each number then we look for is number greater than the max value, which starts at 0. If so, it becomes the new maximum value. So when you step through for each number in the array, if number is greater than max value, as we see there, so is 2 greater than 0? Yes, max value equals 2. Is 3 greater than 2? Yes, then max value becomes 3. Is 3 greater than 3? No, it's equal to. So therefore max value stays at 3. Is 4 greater than 3? Yes, max value becomes 4. Is 2 greater than 4? No. Is 2 greater than 4? No. Is 5 greater than 4? Yes. 6, 7, yes. 2, no. And therefore we can find the maximum value in the array. If we were to make this the lowest number, what would be different? Well, realistically, in the algorithm here, I'd be saying, yeah, if max number is less than min number is less than min value, and I declare at the top here, min value to be 999, a very large number. So if we want to add the contents of an array of numbers, again, standard algorithm. This text was found in the syllabus support document for software design, and so therefore it's relevant to us. If we're going to add contents, let I equals 1, let total equals 0. I equals 1 means the first value, the first iteration, the first value in the array. So looking at element values. Add the number in the array and increment the iteration value, so the array value, until you get to the end of the array, and then, hey presto, the sum is. So that's a really simple array value. Now, it's important here, the note there, that if the number of elements in the array is unknown, so you don't know how long it's going to be, you put something called a sentinel value in. And a sentinel value is a really important value in an array. And generally it's a large number, like 999. The reason for that is because it's then the array recognizes, oh, if value 999 is displayed or is entered, I exit. Simple. And this was actually also used with dates and date stamps. And this is part of the reason why we had the Millennium Bug problem on December 31st, 1999, because a sentinel value for date was 31/12/99. Oops, it turned up. And therefore it could have caused a problem that caused a kick out in arrays, or sorry, in code that was running that had that sentinel value. It's also very important to note, if you're using a sentinel value like 999, that it's a pre-test loop. Pre-test before you enter the loop. So while number is not 999, do the loop in such a way as, well, when number equals 999, you don't enter the loop and process that value in, because that will change totals, averages, and whatnot. We want to separate or generate some random numbers. So 6 unique lotto numbers from a possible set of 100. Ooh, that's a lot of numbers. We have an algorithm that will determine that for us. Starting at the beginning, let R equal random, high value minus low value plus low value. So in other words, it's just going to be a random number between the start and finish values. So random equals high value minus low value plus low value. It's generating a number within that range. Let flag I equals 0 is a way of saying this number hasn't been used. So when it looks at for the flag, and if I equals 1, that number has been used, it will choose another random number. For I equals 1 to 6, in other words, 6 random numbers, Random number, great, until flag R equals 0. In other words, making sure the flag value is set to I have not been chosen already. Keep push through, keep push through, keep push through. Let flag R equals 1 sets the flag for this number to show it has not been used, so that it has been used. So flag R equals 1 means the number has been used already, so we don't generate it again. Now, when we're rolling dice, you have six dice. When you roll them, you can roll 6 1s or 6 2s or 6 3s or whatever. So this flag doesn't happen. When you're pulling values out of a bucket, as you do when you're drawing numbers, for lotto or bingo or keno or whatever, that number has been used, cannot be drawn again. So you use the flags here until flag R equals 0, because flag R says this number's been used already. So it's just that intelligent use of the flags. Okay, so we're going to process a sequential file. Now, it's really important when you're processing a sequential file that you have a kick-out value, which is your sentinel value. It's also really important, as we see here, while data value is not XXX, remember, greater than, less than is the computer's, what the program's way of saying is not. That's a pre-test loop, which means we don't enter the loop when whatever the sentinel value is, as I said, usually 999, or a similar style of number, is found, it doesn't get processed. Let element I equal data value, I plus equals 1, read data value. If your sentinel value is put in there and processed, it will change the structure and the values in the array. Let number of elements equal I also is a nice way of saying I don't know how many elements there are in my array, therefore when I get my sentinel value, I stop processing, that's how many values I began with, which is a nice way of running. An array can be loaded from data values or input from the keyboard, obviously, so you can either pre-define or do some data entry. In the case of this array, begin load array, let I equal 1, read data value, once again we get the sentinel value of XXX. It's reading the values, so therefore it's actually going to be reading a pre-loaded array, which means we can then add the next number in. The use of a priming read to ensure that the sentinel value is not loaded is done here as well. So we get a pre-test loop a pre-test query that doesn't run the sentinel value. Processing of a sequential file, open, input, output, append, etc. The following example writes 10 records to a sequential file called friends data. For I equals 1 to 10, we have a display, which is a prompt. Please enter details for the next person. First name, comma, surname, comma, email address, comma, mobile. Really important there that you have a separation of a comma between each value so that the program knows comma separation means new field in the record. Next I, let first name equal XXX or surname equal XXX. Write this data and close. All right, so what we're doing here is we're writing a comma separated value. And the comma separations are the important part of that because it means I'll go looking for a comma, that's first name. Looking for data, comma, that's first name. After the first comma is surname. After the second comma is email address. After the third comma is mobile phone, etc., etc. So that's a sequential file. And it's really important that those commas are in the right spots. To extract data, now this was in the 2018 HSC exam. So it's a valid point to make. To extract data from the dates and months from the format day/month/year, once again, the program recognises 6 numbers. It knows what each number is supposed to do, so you can pull them out. We need to pull out the first 2 characters and place them in the days column, and the 4th and 5th character to place them in the month column. 1, 2, 3, 4, 5, 6. I don't quite know why the 4th and 5th are in the month column. It should be the 3rd and 4th. Should be the 3rd and 4th. So this. Excuse me. Sorry, Francisco. Yes, you're right. So day is the 1st and 2nd. / there is the 3rd character. So the 4th and 5th are the month. Well done, Francisco. So begin, find days a month, get the data string, let start day equals 1, let start month equal 4. In other words, start day equal the first value, start month equal the 4th value. The 4th character in the data string is the start of the month. extract from the start day characters for 2 characters from the string, extract from the start month, from the 4th character for 2 characters, and display the month is characters 4 and 5. So what that's doing is reading a data value and extracting specific characters from that, which is pretty cool. Defining a key field for relative files. Now we've met relative files before, they're databases. And so therefore, instead of just reading a sequential file from start to finish, imagine if the ATO, for example, had a sequential data file for every person with a tax file number. So you'd start with your tax file number of 000000001 and go up to the highest tax file number value of 9999999, I think it would be, and read them sequentially. Now, it's great for you if your tax file number is early, but if your tax file number is towards the end, 834728294, which isn't my tax file number, I do know my tax file number, I'm not telling you guys, reading a sequential file of millions or tens of millions of records will be very, very slow. So what we do instead is use a key field which will be searched for. And if you search for a key field and find it, search all those data, that's the value I want, there's your key field. So once again, display, please enter details for the next product number, description, quantity, price, and write that value. The note, the use of the variable product number is a key field specifying where this record will be written in the database, which is really cool because that means that instead of saying, wait, look, read, that's where I'm going to go next. It's, I'm going to go into position 7, 1, 2, 3, 4, 5, 6, 7, right. So it's just randomized access, much faster. Opening a data for relative access, once again, you'll see we have a sentinel value. Please enter 999 here is a sentinel value. So it's a kick out. Get required product number. I want product number 7. Simple. It then says reads product 7 and reads product 7 and the rest of the values alongside that. Quantity, pricing, etc., etc. If record not found, if there is no product ID number 7, it will come back and say, sorry, no such product. It's really simple. And 999 is an exit code. So once again, processing a relative file using that sequential key or using that primary key field. And this is a lot of stuff, retrieving, writing, and updating a record of a relative file. It's actually broken down into 3 sections. We have the read section, the not found, it's a check there, is product number, is this the correct thing you're looking for? And then just the view. So it's actually quite a simple algorithm, even though it is quite long.